So I know my microphone is a little off right now, but I will get that back over to you. So hopefully this is loud enough for you, and what I just want to do is show you how to, when given a zero to a polynomial, find all the remaining zeros. And there's a couple ways that we can go about this, and one of the more common methods that we're going to use though is by applying synthetic division, because if we know that this is a zero, then we know that the zero, by synthetically dividing, will be able to give us our remainder that we can further factor or break down to find the remaining zeros. So if I'm given a zero, then that means I can set up my synthetic division, and that marker doesn't work. So let's go to the next one. So I'd say -3, and then I set up my synthetic division. Now remember, when setting up synthetic division, we need to make sure we take the coefficient of each and every one of our terms. So my first coefficient is 1, -2, -21, and -18. So in synthetic division, first thing I do is bring down the 1. 1 times -3 is going to be a -3. -2 plus, or -2, and then remember you add vertically, so -2 plus -3 is going to be a -5. -5 times -3 is going to be a positive 15. -21 plus 15 is going to be a -6. -6 times -3 is going to be a positive 18. Bring that down, that's going to be me with 0. Now, when you're doing synthetic division and we have this as a remainder, what we like to do is to say, all right, that's our remainder, our constant, our linear term, and our quadratic. Therefore, my remaining factor, if -3 is a 0, I have a remaining factor of x squared plus x, minus 5x, as -5 is the coefficient of my linear term, and then -6 is my constant. Now, I need to be able to determine this and see from here what are my other remaining factors, or zeros. So therefore, what I can do to find my remaining zeros, I'm going to set it equal to 0, and now I can factor this. Well, by going by factoring, I can determine this is going to be x minus 6 times x plus 5 equals 0. Therefore, by applying this zero product property, I can say that x equals 6 and x equals -5, or x equals -5. Now remember, my other zero was -3. Well, I can also write that as x equals -3. So therefore, the list of my solutions for this polynomial, when given one zero of -3, my remaining zeros are going to be 5 and -5. So there you go, ladies and gentlemen. That's how you find the remaining zeros given one zero. Thanks.